Just for check, it'll be fine. All right, everyone, if I can have your attention, it's 7:30. We're gonna go ahead and start the main part of the meeting.
Hear ye, hear ye.
Ah.
Gotta speak, close.
You got the mic turned all the way down. Yes.
All rise. The Honorable Al Dove now presiding.
All right. Thank you all for coming. Great to see such a good turnout. I know you're not here for me. Jeff will be speaking in a few minutes. So first order of business, as we usually do, please turn off any noisemakers you're carrying. Turn your phone ringer off so that you're interrupted. Don't worry, I will remind you and myself at the end to turn it back on so that you'll be able to receive calls again. And now I will, are we on Zoom?
Yes, we are. We are live.
All right, we're live. I will try to stay on camera. Hi, everybody. We'll do what we usually do, which is a quick roll call. We're going to try and be like contesters to keep the rate up here because we got a lot of people. We have a lot to get to this evening. So the roll call is simple. It's just your name, your call sign if you have one, your QTH, what town you live in, and tonight's question: what is the most recent radio project that you've done or that you're working on? Okay, so I'm Alan, AB1XW. I live in Longmeadow. I'm an HCRA board member. Most recent project I just finished was I finally put my offset and attenuator for RDF into a little project box, which I had to drill out from an aluminum box because I don't have one of these devices. Yeah. Yes. Yes. Yeah. So it will then go to
Ken, 81KU, South Hadley. I'm an HCRA board member, your Zero Beat editor. Alan's graciously taking over for the next month or so. From South Hadley, by the way, hopefully the last time I say that, it should be Chicopee next time. Projects, trying to learn that FT 710. First radio with that type of menu system, so it's a new ball game.
Marvin Turner, W0MBT, and working on waiting on my new Flex radio to arrive so I can do a remote setup. Also a repeater, my remote location, Wisconsin. So.
Where are you from?
Oh, Southampton.
Southampton.
Yeah.
Mike, 81 WAM, Amherst, Mass. I'm working on a rock mine too.
Cool.
And our new treasurer.
Yeah, our new treasurer.
Newest board member.
Yes. Hi, George, KC1B from Summers, Connecticut, former treasurer. Turned it over to Mike today. Actually, the most recent project I've been working on is that poured cement yesterday for a new tower.
Wow.
All right.
But that's, I didn't do much, I just watched the whole and I wrote the check.
Yeah.
Writing checks is important.
That's the hardest part. John Zimmerman, West Hampton, KC1 CXD, and mostly recently trying to get my antenna back up and working.
Jim, KK1W, live in Brimfield, Mass. Former a lot of different things in HCRA. Actually, the last couple of weeks, I've been rebuilding a Craftsman 10-inch table saw, so I can build a wooden cap.
That's radio related.
It's kind of.
Smitty, Kilo Charlie 1 India Kilo Alpha Net Control for Aries, and living in Westfield and doing mobile in Southwick on weekends, my campsite. Latest project, I got a D75 and getting APRS set up and found the one sweet spot at Barnes Airport where I got it just enough of a hill where I can hit the repeater 27 miles away with 5 watts. So that's what I'm working on.
Mike, Kilo Charlie 1 India Zoom Charlie, NCS for Aries and Skywarns of Agawam, Mass. And I have not worked on any ham radio projects since the ham exposition. I'm busy doing other family stuff.
Fair enough.
Larry, KD1RV from Chicopee. Right now, working on
I have a 891 and I'm putting it in a small backpack from Radio Made Easy. I got the Armor Walk brackets for the side of it, and now I'm getting ready to put an LDG 100 A antenna tuner in there. It's a very smaller than the backpack I had that I could take portable in my mobile, or I could use it as portable out in the field.
Nice.
Paul, N1D from Leeds, secretary, still. Latest project, I built two 5-watt True SDX portable transmitters. I've got a third one on the shelf ready to start, so I'll have all panels covered with 3 different ones. Fun little project, if you don't mind winding little tiny.
Tim, AC1 FRG, East Long Meadow. Basically relocated a couple of antennas, that's about it.
Attorney K1EJB Ludlow. I guess my next project is trimming branches away from my dipole.
AA1UE Southampton, latest project is putting 900 megahertz in the car while we still have it.
Todd N1GNX, West Springfield, working on an end-fed antenna.
Across.
Mark, WH2ILS, Belchertown, in the process of getting permission to put up a one wire and a 2 meter 40 antenna at the Pine Valley Park Plantation. And hopefully, maybe once I get the permission, it gets ask for some help get putting them on.
K1KI, in West Suffield, Connecticut, 1,000 feet south of the border. And good to see a bunch of friendly faces. I've probably been here 7 or 8 times to these meetings, and I love going to your field days. So my projects this summer have been to do antenna maintenance and cut all of the damn branches and trees and leaves and stuff that grow around my towers.
AC1, no, Jeffrey from Holyoke, we went this thing, gave me a 8 box hunt antenna.
Yeah.
Looking forward to trying it.
Did you visit our field day site?
I did.
Excellent to see you here and congratulations on the license.
Yep.
All right, next up.
John, A1CV, the biggest project's been the hole that his cement went into. The manual labor to that thing, and just putting together the mausoleum that I inherited.
You're everyone Q from Moswick, and my project is continue working on my invisible antenna so that I can run it on my coin.
Well, I hope you don't miss it.
John K1VY of Hampden. I've had to replace my dipoles. I have the wires end-fed dipoles. I've got like 4 different antennas and it all went down and won't back up.
Wow, K1 Mayo from Southwick. Let's see, projects, latest as of yesterday, working on getting a 3-foot magnetic loop antenna made out of hardline to resonate on 160 and 75, and it's working. So.
Really?
I'm Pete, N1AGV from East Hampton. Last thing I do is program up a couple HDs.
That's a project, definitely.
For Shrivers and stuff.
Next.
Beth, N1BIF from East Hampton, and the closest thing I do that's Pam adjacent is I check where the weather sign is each morning. It's not my job. Are we going out or not?
I don't have a call yet, but I am studying. Last thing I did in radio was I went to the Hume exposition and manned the photo booth.
Nice.
I'm Larry, W1AST. I'm the ARL affiliated club coordinator for Western Mass. I'm a retired board member after 20 some odd years. And my last project was wiring up a ACOM solid state amplifier and tuner to my radio.
All right, I think we're back here now.
Ron, 81ZJ out of Belchertown. And this project is rebuilding my DX commander that was not built during the last
Marty, whiskey one Mike Fuel in the Bravo in Long Meadow. I'm bringing back a derelict station that they haven't operated in a while, and today, along with the head of Muppet Lab, we started dealing with a 160 and we got 3 bands, 260 and 160 left. That's like the DXDC. So I've been busy.
All right, next row forward.
Brandy, oh, go ahead.
No, Brandy, you go ahead.
No, you go down with the.
I'm Kurt Kaden, our chief of Magawam. No projects.
Cool.
Roger, 51LY from Chicken. I'm working on, I just finished up a 0 to 30 volt, 0 to 10 amp laboratory supply, which I use for prototyping, and also I can also use it for testing mobiles and radio gear. So that's my finalized project, and I'm glad I'm done with it. It's a lot of work, but everything's good.
I'm from London, and I have no recent project.
Let's continue across that row and then come back.
Okay. B, Springfield, Kilo Charlie 1, Kilo Echo Zulu. Project that I'm just starting on is reconfiguring the box that I showed you in April. I'm gonna put, take the battery and charger out and, put 91 in.
Steve, 31, Connecticut. And my latest project is trying to take a DMR radio and a D-Star radio and put it into a DeWalt everything.
Lauren, KB1W2K, Elton, Connecticut, no projects.
Wayne, KC1FQV, Elton, Connecticut. The only project that I tried to do is hang wires so we could listen to the 10-meter net.
All right, and I think we're now back to
Brandy.
Brandy, you go ahead and go. Yes. We'll go right from, well, yeah. I know you're in a hurry, so go ahead, Brandy.
I started too early, so. Brandy, N1FJ, I like Kurt's answer, but I'll go back a couple of weeks when I drove out to add a couple of summits to my summits on the air store. Sort of half-assedly going towards my second mountain goat. Wow.
Okay.
I have 1,600 in some folks.
Fred?
All right, I'm Fred AB106 from Hollis, New Hampshire. I constantly measure new hams in my shack and try to help get on the air. So I'm going to put up a simple 20-meter dipole and a 100-watt radio, which I think is a pretty good HF starter station.
Yeah.
Use that to help start.
Nita, AB1QB, I'm also from Hollis, New Hampshire. I've kind of lead a team of folks from our club who teaches, who's going to be teaching the extra class in December, and my big project is updating all the slides for the new question pool.
Finally, the back row.
Carl, give you one project.
Okay. Quinn, good to meet you. Hi, I'm Alan. Just your name and what you're working on.
I'm a college student. I'm the station manager for Amherst College Radio. I have no experience with ecology, with amateur radio, so I'm here for a school project. And I'm beginning to meet you all in the morning.
I go around here. Got a couple. One of which is removing a tower from his house, where I used to live, because he's dead.
So what, Kilo 1 Fox Whiskey Mike, and, I've got no projects, but I do have an antenna if anybody needs one. They're Teething Hills.
What's that?
And finally,
Okay, HC1 OVR from Southampton. The last radio project I worked on was just cleaning up coax coming into the house, and put a watertight box on the exterior of the house.
excellent.
Very much for that. That's about it.
All right. Okay, a couple other quick things. If you are an ARRL member and you're gonna renew, please renew through the club because we get a little kickback at no extra cost to you. That is in zero beat. If you are not a member of the ARRL, you should join. It's a good organization for hams. Tonight's speaker will be Jeff Vale, NT1K, who will be talking about 3D printing for ham radio. And I am definitely looking forward to that talk. He has an opening act though. Before Jeff talks, we'll be hearing from Tom Frenet, K1KI, former New England Division Director for the ARRL, and the current New England Division Director, Fred Kemmerer, AB10C, both of whom are running for one seat, and when the music stops, only one of them can have it. So they requested this time, and I agreed to give them each 5 minutes and 5 minutes only, because we have Jeff's talk coming. I have a timer. Go back, Jeff.
I was gonna say,
Closer.
you beat me to it.
I'd rather go second.
You'd rather go second, Fred? You go first?
Yep.
Okay, come on up.
Figure who's gonna win the coin toss?
Great. Well, first of all, folks, thanks for having me here tonight. I appreciate the opportunity. Nice to see everybody again. I think it's been since about Christmas. I was with you the last time. So, we're gonna hear lots tonight about problems that the ARRL has. And I think most of us that are honest know that those issues exist. We're worried about protecting our bands. We're worried about the fact that people are aging out and the participation in amateur radio is not on the upswing. We're worried about things like RFI, HOAs, and a lot of other things. What I would say about this process of picking a director, it's pretty easy to lay out all the problems. I think we know what they are. What really matters is who's got a plan to solve them and who's got to do it. So what I've been doing for the last 2.5 years is focusing on a few things. First of all, I think getting new people, new hams of all ages in amateur radio and getting them active on the air is absolutely crucial. That's how we get amateur radio growing. That's how we get ARRL membership growing. And most importantly, without that growth, all the other things we want to do in amateur radio, MCOM, protecting our rights and spectrum, so being big enough to matter to the FCC, none of that happens without that mission. Now, I spent the last 2.5 years, pretty much 6 days a week, working on initiatives with the board to try to get the ARRL focused on this mission. We made a lot of progress. We've got stuff going to have the ARRL provide license classes. We recently brought Gordon West and his books into the ARRL fold to help us with that, help us promote licensing. We put together programs to help clubs come up with content to measure, help new hams get on the air. Many of the things that I'm personally involved in and have been since I've been a ham. And also, we've put together a program with some money we got from the RDC, about $500,000, to fund clubs that want to work on these problems and give them resources, tools, stations, and support so that they can grow amateur radio. And that may be one of the most important things the ARRL has done. And that's a good project. The foundation got the money. ARRL folks, as part of a committee that I led, set up that program and got it rolling. It's given out $500,000 so far. We're in the process. We've got another $500,000 from RDC as a result of doing well the first time. So the total amount of money we go to close by the end of the year is $1 million to work on these problems. Second thing, regulatory. Everybody agrees that the most important mission that the ARRL has is to protect our spectrum and our rights as hams. There's only one candidate in this race that actually has ever worked with the FCC to set policy. I spent 2 years on something called the FCC Technical Advisory Committee, which is a group of industry experts FCC to help them form regulatory policy on things like spectrum protection and interference protection, IP networks, broadband access, and all.
The bill that, the Fred just mentioned for changes to the technician license, so techs could use digital modes on HF, which they can't right now. I mean, you have a no-code tech license, and what do you get? CW bands on HF. That doesn't help very much. So anyhow, the FCC is very important to work with often, and if the FCC is not going to move things on their agenda, we need to be talking to senators and House of Representatives folks, because they do the oversight of the FCC. And they do listen when a congressman asks for an update on a topic. So we have not done that much in the last 6 years. There are 2 bills in Congress that would help for homeowner association issues. Those are stuck. Is the best way to describe it. On one of the websites that tracks bills before Congress, one of them says there's a 2% chance, and the other one has a 3% chance of actually coming to be law. And so a lot more lobbying and contact with folks is absolutely needed. And that's probably the most important job for the ARL, is to both preserve spectrum and keep the I should stop.
That's it. That's right.
Thank you.
Right.
And I've got a handout I'll pass out, as your speaker comes up here, and thank you very much, and look forward to hearing from you and questions later.
Anybody have pressing questions now? Ready to get to Jeff, and then you can talk to these guys afterwards? All right.
Thank you.
Sounds good. All right, Jeff,
All righty.
take it away.
I'd like to thank both Tom and Fred for coming out and speaking. I feel that the ARL matters are very important to everyone involved, so I'm glad they came out, and I wish them both the best of luck. For those who don't know me, my name is Jeffrey Bale. My call sign is NT1K. I was a past president of this club. We'll try to go through some of these slides, and that's all about me. You guys don't care. I did say Holiday Inn Express, so that covers, no. I have a background for about 20 years in CNC machinery. For the past 10 years, I've been doing a lot of drafting work. So I got into 3D printing probably about 2009-ish, and I've been doing it since. It's partly a passion of mine. I get frustrated, and just like camera radio, I'll abandon it for a while, then come back. But it's a hobby of itself at times, and I love it. Because it's also an outlet for my creativity, for mechanical design, which I do quite a bit. Let's see, yeah, that's all that. We'll go into it. So what is 3D printing? Well, it's material that is joined or solidified using computer controlled to create a 3-dimensional object. It's also known as additive machining, but a lot of people will just say 3D printing. The history goes back as far as the 70s, but you didn't see them much really in use until like the late 90s, when manufacturers were starting to adopt them and use them for prototyping, making tooling and dies and molds. So that helped us with the process. Bunch of engineers and software developers got together and they developed what was called the RepRap project. And RepRap is a replicating rapid prototyper. And that was started around 2005 as a way to bring the cost down, use off-the-shelf parts, and to make it more affordable. And that's what started getting a lot of the home users involved. This printer right here is one of the first 3D printers from the RepRap project. It's called the Mendel, and that was developed in 2009. So for the past 15 years or so, it has been quite the journey with 3D printing. What's cool about these little 3D printers is that they can, with the RepRap, they can replicate almost 70% of the parts. With this printer right here, you'll see, if you'll come up later on, you'll see that a lot of the parts are printed. So that's a pretty cool thing about 3D printing, is you can make other 3D printers. So this is a 3D printing farm.
this is a Prusa factory that actually makes that printer right there. And that's basically 3D printers making other 3D printers. So, no, you can't buy a 3D printer, print your new printer and ship it back. I wish it was that easy, that'd be fun, but, there are some parts that you can't 3D print, like servos, power supplies, and, controllers and stuff like that. So, of course, the first thing we gotta do is go over safety. There are potential dangers with 3D printing. Over the years, though, it has become minimal. The first and foremost is there is a potential for fire. You have a hot end element right here. These printers are a little nozzle. Think of it as like a glue gun, and you got a heated bed. So electricity is flowing through it. It's generating heat. There are thermocouples that will measure the temperature, send it back to the controller to tell it what the temperature is, and it uses PID tuning to keep that temperature. But sometimes it glitches and it runs away. And the photo you see right here is one of some of the fires that happened early on with a printer called the ANET A8. They were well known for catching on fire because there was no safety programmed in the firmware. So what a lot of people did was they would buy an A8, they were aware that the fire potential was there. They, as I said, there's a big, I didn't say, but there is a lot of open source to this. A lot of people design parts, add parts. So someone actually developed a different firmware, and a lot of people adapted the firmware. It was called Marlin at the time, and that enabled all the safety features. So you don't see fires too often anymore with 3D printers, but it is still a concern. I wouldn't necessarily walk away from one running, but a lot of people do it. I don't see many fires as often. I do pay attention to the scene very well. You also have the potential for burns. As I said, there's a hot end. The bed also heats up. Sometimes you might have to reach in and grab a part or change a nozzle, and it might be still hot. So there's a potential for burns. And then there's the stuff you can't see, or you can't see, like VOCs. Since these things heat up, you're heating up plastic, you're extruding it. It releases gases, fumes, and it can really, really, really do bad to your health, especially depending on the type of plastic you're using. There are some plastics that are better, but there are some plastics that are not good. And that would depend, and depending on what you want to make and what plastic you want to use, that will factor what type of printer you want, where you want to put the printer, whether or not the printer wants to be in an enclosure, filtering, fan, stuff like that. So that's something to consider. There are people that run 3D printers in their office while they're sitting next to it. I can't comment on it. But another thing to consider is nano-sized plastic parts. As I said, these printers are extruding a piece of plastic through a heater. So as it's coming out the other side of the nozzle, microscopic little plastic particles come out of it. You'll notice it'll be stringy, and so that's another thing to consider, because you can inhale those little plastic particles, and it'll be full of fun. So safety is very important. I'm going to publish this. I'm going to send it to the webmaster, to Vanessa, and we're going. These links are to some OSHA and NIOSH and CDC documents that can help you if you decide to get into 3D printing, or if you do have a 3D printer. Some of the safety considerations and things you can do to minimize the risk involved with 3D printing. But it's not that bad. There are millions of these printers out there. Very rarely do I hear stories, at least of fires and burns anymore. But the VOCs and the particles, it is a concern. And that's where, once again, buying the correct printer could help. So applications for amateur radio. That's basically why I'm here, is to show you what this 3D printing technology can do with amateur radio. So back in 2018, I saw the cover of QST, Bob Heil's pine board projects, and it's very nostalgic. You know, I do appreciate, the dead bug style, Manhattan style construction for PCBs. And I did like Bob Heil's article, but we're in 2024 now. I mean, we could do a lot better nowadays than just building stuff on pine boards. I mean, it's still cool and all, but for the time I would have took to make that pine board, I designed this within 15 minutes, and I can have it printing while I'm working on the rest of the project. And what's cool about that with the 3D printing is I can incorporate some of the features to save costs and save time and money. For example, Bob had his tube elevated. I was able to just put the posts in there, some binding strips on the back, terminal strips. You just put little pieces of metal, drill pieces of aluminum, and you can even save a few bucks. So that, I'd say, one of the biggest applications for amateur radio. A lot of people do their projects on boards and breadboards and stuff, and as long as it works, that's what matters for some. But in this day and age, you can definitely make it look good as well as operate good. Another thing to consider is antenna parts, especially for your portable operators, for the SOTA operators and stuff like that, or POTA. I'm sure you all have seen these. They're little winders. They can also act as insulators, so you can wind your antenna and your rope to use as a guy wire, and you can print these. I mean, that's a great use. Some other uses, for example, if anyone ever had to deal with a Mosley beam, you'll see these clamps that as soon as you take the bass plate off, they fall off and you never see them again. So, and of course, Mosley does not sell these anymore, the clamps, so I reversed them and I printed my own. Now, how they will hold up compared to the aluminum one, I can't make any guarantees, but if you need something in a pinch, you can definitely design it, print it, and implement it within hours. Organization, 3D printing is big time. There's a lot of things you can do if you're into organized. I'm not so organized, but there are people that are very organized, and you can print things that can help you with your organization, like, you know, a tool drawer. We'll get into a little deeper, but you know, I got like a little battery holders, radio holders, things to organize my mess. Of course, you can also make replacement parts. I don't know where my VFO knobs. I made some VFO knobs for a project. You can make text fixtures. You can do prototyping, and you can make, of course, custom brackets and mounts. As hams, we have a lot in common with the 3D printing community. There's a big push for open source and sharing of prints and ideas. A lot of the 3D printing people have interest in electronics, interest in making things better, stronger, quicker, and of course the endless arguments about little particulars that may or may not make a difference, just like ham radio. So there are some myths that I hear whenever I bring up 3D printing. People say, well, you know, I hear of this, I hear that. Well, some of it's not exactly true. Like, you can easily make parts with the push of a button. No, I wish it was that easy, but no. However, over the past 5 years, 10 years, it has been getting a lot better than when I started. Another myth is that you can only make small parts. That is also not true. The University of Maine 3D printed a boat, an actual full-size boat. I would say more than 50% of that boat is 3D printed. They had put wood in some areas to support it, but they made their own boat with a 3D printer. Of course, it was a much larger 3D printer than I would have. Another myth is that it's not structurally sound. There is some truth to that, because 3D printers, they're printing layer by layer. Sometimes the layers can delaminate. Sometimes it can break. It all depends on how you design it and how it's printing and the material you're printing with. I'm not going to say it's good as steel or aluminum, but it's not weak either. It all depends on how you design it. What I have here, it's a little image, but at my work, I do a lot of sheet metal fabrication, and we'll even make custom-made press brake tooling to bend metal out of 3D printed parts. And they hold up. They hold up. We can bend all sorts of aluminum seals with it and different profiles. We design tools and we print it. And if we like it and it works, then we might reach out to a tool and die maker to make a set depending on the customer. So it comes in handy. Another myth is that's going to replace traditional CNC manufacturing. It won't. It's just the time it takes to 3D print something is not worth it in a production environment. But for prototyping, I think it would definitely take over a lot of the stuff in prototyping. Another myth is that you need to have CAD experience. You don't. That's what's, a lot of people are, "Oh, I don't know how to design anything, I can't design, I don't, so why would I get a 3D printer?" Believe it or not, there are tons and tons of repositories out there where people share their projects. I'll get into that a little bit later. Another myth is that it's very expensive. That's not true either. You can get printers now for brand new for $130 for certain types of printers. And you have Facebook Marketplace, you can get them certainly a lot cheaper because there's a lot of people that get into it, especially with the older printers. They get frustrated and then they sell their printer. Right, Jim?
Right.
Yep.
You bought it.
I bought one of his printers way back. 3D printing used to be a hobby of itself. You had to be very involved. When you like, for example, this printer was a 2000 and this is a 2015 era printer. And there was a lot you had to do with it. You had to chase a lot of things. The bed had to be perfectly level. The filament speeds had to be the speeds of the extruders, the speeds of the servos. They all had to be tuned, and you had to be constantly making adjustments. And then you would load a different material in it or a different roll of filament, and it would all change again. So that has been slowly over the years been becoming a lot better. There's more turnkey push button style printing going on, which is attracting a lot more people into the hobby, as well as it's using to supplement other hobbies. It's no, you're no longer, you're no longer dedicating time to printing something that you want to put in your car, or you could just load the file, load it and go and print and then come back later and take it and put it in your car or whatever project you're working on. So it's certainly improved. So what would you need if you wanted to get into 3D printing? Of course, you need a 3D printer, and there's so many different types of printers. I'm not gonna go through them all, but I will have some recommendations. You'll need, of course, 3D printing media. I mean, you can't print without it. What we'll be discussing today is mostly filament printing. There's also resin printing for the home user. And it's basically this stuff right here. It looks like a weed whacker line. As a matter of fact, they started off with the RepRap project with weed whacker line because it was easily available. There was no one making 3D printing filament, so they used they went to the hardware store, bought weed whacker line, and that's what they started with. So the 1.75 millimeter diameter that's typical of these filaments is the reason why they went with that was because of weed whacker line, lawn trimming line. Of course, you'll need a computer and software. These printers operate on code. It reads a line of code at a time, and it takes the instructions from the code and tells which servos to move. You'll need a software, a decent PC, because you'll be dealing with 3D rendering, 3D modeling. I'm not sure of exact PC specs. That would depend on the software you'd want. Or I'm not even sure. And there are some Mac software. I'm not sure about Linux. I think they run a lot of the slicing softwares in Wine, but I'm not too sure. But for Windows, there's a ton of different software out there. CAD software, I'll have a slide dedicated to that. As I said, you don't really need to know CAD for 3D printing, but it would help if you did have drafting experience. It would definitely make your printer more useful. And there is software out there that is both free and paid versions that are out there, which I'll get into momentarily. Some measuring tools, especially if you're doing the drafting side of it. Pair of verniers here, I would say, is one of the best tools you can buy for 3D printing, especially if you're building stuff that has to fit together or you are designing stuff that has to fit into other things. So a pair of verniers can go a long way. These are old dial verniers that I occasionally use. But you can go to Harbor Freight and get a digital verniers, 6-inch verniers for like 20 or 30 bucks at the most. And they will do the job just fine. You don't have to measure down to the tens of thousands. So that I would say was my most used tool in 3D printing, along with a scraper, which I'm using to support, and wire clippers, flush cutters. So flush cutters are one of the best tools you can use. Then you got, the cleaning stuff, like you need to clean the beds, denatured alcohol or 90% isopropyl alcohol that you can buy at the pharmacy. Some glue sticks, because sometimes you have issues with adhesion, which I'll get into a little more. So for the home user, I mentioned that there's multiple types of 3D printers. So what are they? Well, the one that is, I would say, is the most popular is FDM, which is fused deposition modeling, or they also call it fused filament fabrication. It uses filament similar to a weed eater, as I said. It's extruded through a nozzle. Think of like a hot glue gun, you know, or use a hot glue gun. It's almost like that, except it's controlled by a computer. It's the best entry-level CNC for 3D printing, and it's also the cheapest. You also have SLA, stereolithography. It uses a vat of polymer, a photopolymer resin that reacts to light. So it uses a UV laser to draw each layer. And of course, I got a model here that my coworker who has a resin printer made. And what's great about resin printing is that you can get very detailed, but it's not as strong compared to filament. So there are uses for resin printing. For amateur radio, yeah, not so much, but if you're in the tabletop gaming, I would definitely have a resin printer over a filament printer any day. There's also SLS, which is similar to stereolithography, except it uses a powder. You don't see too many of these in the house in home use because it's super expensive. And then there's a bunch of other types that I'm not gonna get into because they are mostly used in industrial applications and cost way more money than a ham radio operator would probably spend on a 3D printer. So since we're focusing on just these filament printers, a lot of people ask me, well, what, there's so many different types of filament out there, what do I use? So these are the ones I would say that are the most used within 3D printing. I would say the most used is called PLA, which is polylactic acid. It's derived from corn. No, it doesn't mean you can eat it. It's easy to print. Of course, with PLA, which I think this is made from PLA, it will get brittle over time, and especially with UV exposure. So it's got low heat resistance. It's mostly used for toys or stuff you're doing on the inside. I would not use them for outdoor applications. So if you just want to make a quick cover or something, PLA is definitely good for that, especially if you're prototyping and you don't want to use more expensive filament. The next thing that a lot of people are using is called PETG, is polyethylene terephthalate glycol. It's strong, it has decent heat resistance, and it provides a smoother finish. However, it can get very stringy. So if you're dealing with things that have gaps, or you're trying to print over a gap or something, you might get some stringing. That's where you start having to dive into the settings of your printer and adjusting things like retraction. It can get a little intensive, but as I said, the technology is improving, the printers are improving, the software is improving, so that's becoming more and less of an issue than before. Then I get into the styrene. Personally, I do not use the styrenes. I stay away from them, but a lot of people do print with them. I personally wouldn't really suggest using styrenes like ABS. You all know what ABS is. Most of the car parts now are made with ABS. Your dash, your center console, everything is made with ABS. It's strong. It has decent heat resistance, and it does provide a smooth finish. You can get it really smooth if you put it in an acetone bath, but I'm not going to get into that. It's very fumy. So if you have your printer out in the open or in a living area, everyone will know you're doing ABS. Then the other styrene, which I'm not going to pronounce, ASA, it's similar to ABS. It has, but it has more UV resistance, better tolerancing too. However, it's just as fuming, if not worse than ABS. So I tend to stay away from those. And then there's TPU, and it has similar characteristics to rubber. It's flexible and soft. So if you needed to make feet for something like you're making an enclosure, you want to put feet. TPU would be that. I thought I had it with me tonight, but I didn't. But I made a phone case for my iPhone using TPU. It's pretty neat. And there's a bunch of others, such as wood. You can buy filament with infused wood. As a matter of fact, this is one of the items that has been infused with 30% wood. There are other plastics with other mixtures in it, like these here, these little Baofeng radio holders, which you guys want one. These are made with, they're infused with carbon fiber. So it does add more strength to a product. And then there's some dissolvable resins and dissolvable filaments that some printers that can support the multi-filaments can print your supports in one media while printing the main thing in like PETG, and you can submerge them in water and the supports will melt away. So it makes time, it can cut a lot of time, but those filaments are quite expensive. The common parts for an FDM printer, of course, you have the frames here. This is basically what everything is built off of. The Z-axis, which controls the height. So these two ball screws right here will move the carriage up and down. You have the X-axis, which is right here. This is what, and then you have the Y-axis, which this bed will move in the Y direction. You have the hot end, which is right under here. The heated build plate, which is on top of the Y-axis. And then there's the control panel. Some printers don't have control panels, but most do. And behind here's a power supply and of course the microcontroller that controls all of it. And some of the microcontrollers are 16-bit, some are 32-bit. It all depends on your wallet. So 3D printing is a balancing act. You have to keep in mind your nozzle temps, your bed temps, your speeds, how much is it extruding, and the motion settings. Most 3D printing software that you'll use, slicing software, will have profiles depending on the material and the quality that you're looking for. And it takes a lot of the guesswork out of the situation. So most what people do is when they get a 3D printer, they'll get a slicing software and they'll load a 3D model file into it, slice it, and they'll start printing. It might go great the first time and you're great, and then it might not, especially with older printers. There's so many variables involved that it can lead to more difficulty the more involved you get in 3D printing. However, as I said, I've been saying it quite all along, the technology has changed quite a bit over the years, and it's getting a lot easier. So CAD software, if you ever decide you want to design your own parts, there's some cool things out there. So a lot of these software that generate the G code for the printer uses, it'll take a solid model file that's created by CAD software. What a lot of people use in the 3D printing hobby is Fusion 360. It's made by Autodesk. It's the same people that make AutoCAD, Autodesk Inventor. You can get a free version of it for personal use. And that's the most commonly most common used within the 3D printing circles. And then there's some browser-based CAD software. You got Tinkercad and Onshape. I've been messing around with Onshape, as a matter of fact, just to make sure I could still do things. I designed this guy in Onshape just to see how well it works. And I'm personally a Autodesk Inventor user and a SolidWorks user, but it wasn't bad using these online websites. So those are free. The only issue, I prefer Onshape over Tinkercad. The only issue with Onshape is you have to share your designs. And I'm not sure who you're sharing them with, but they have to be out in the open. So if you're trying to design something you're trying to protect the IP, you don't want to, your intellectual property, you might not want to use Onshape. There's also FreeCAD. It's an alternative based to Fusion 360. A lot of people use it, and there's a great support network. I just feel it's a little harder than Fusion 360. I might be biased because I'm an Autodesk user. And then there's the SolidWorks, or there's OpenSCAD. If you know how to do code like C++ and basic stamp, and basic, and that might be up your alley. I tried using it. I can't code, so. But the cool part about the OpenSCAD is that it allows users to modify things a little easier if you understand the code. I had trouble with it. And then the other two, which I'm not going to link, are the big money ones, SolidWorks and Autodesk Inventors. But if you're trying to make a business out of it, then I might consider one of those two options for software. So cool thing is, as I said, if you don't know how to design it, you can download it. That's great. Sharing is encouraged within the community. Many people share their projects on repositories. As a matter of fact, almost everything you see on that table, almost, is found on a repository. Yeah, you can even download a car. So some popular projects are forked, so if somebody makes something and it gains in popularity, a lot of people will take a copy of it, make their own interpretation or add their own flair to it and upload it as well, so there's multiple options. And I would say for 3D print, and I'd say the most popular repository where you can download STLs and files that would need for your slicer would be thingiverse.com. Site's a little buggy, but it's free, and that used to be the site that everyone went to. Of course, some other sites have popped up over the years. Printables.com, that was sponsored by Prusa. They wanted their own repository, so they sponsored a website, and a lot of people use Printables. There's things.com. GradCap, that's more for technical applications. You can download whole factories and 3D models that someone made. But it's not really geared towards 3D printing, but there's a lot of 3D models on there. There's Maker World, which the Bamboo Labs printer, which I'll get into a little bit later. They have their own repository. Then there's a site that I like. It's called Yegi, Y-E-G-G-I. I'll share this online. But Yegi is basically a search engine for repositories. It goes throughout all these other repositories, looks for stuff and catalogs it for you. So I would start off with Yegi and then go to the other ones. And then there are other repositories for like niche aspects and hobbies. Like if you're into tabletop gaming, there are tons of repositories for that. And for some reason, I came across a lot of biomedical stuff for for that students use for studying. So I thought that was pretty cool. And if you're in a remote control, like airplanes, quadcopters, drones and stuff like that, there's another set of repositories for that. So it's not just for hammering, it's not just for making stupid trinkets. There's a ton you can do with it. If you don't feel like having a printer, or you don't want a printer, or you're too concerned about the fumes and nanoparticles, well, guess what? You can design something and have someone print it for you. There are many services out there that will print objects for you. You just need to provide them with the model, type of filament, resin, plastic, metal. Yes, they even print metal now. And they'll do the work for you. And of course, it'll cost you, but it's beneficial for small batches, and especially if you don't want to buy a 3D printer. And the service called, services include MakeLab. I've used MakeLab once, they were great. Make XYZ is also great because it's crowdsourced. People with 3D printers can volunteer to do jobs. Well, I wouldn't say volunteer, but they will take on jobs, get paid to use their 3D printer. There's Shapeways, and for anyone that makes PCBs in here, JLC also does 3D printing. So there are a lot of services out there that you can use, and you don't even need to buy a printer. Of course, it'll cost you. So as I mentioned, everything goes into these 3D models go into a slicing software. It breaks the 3D model down into layers. It assigns an X, Y, Z extrusion and servos. So it assigns all the movements in code. So and the software will also add supports. For example, let me see here. Anyone with like overhangs, like this is a antenna coil form, and you got these overhangs, so you can print supports so these don't droop, because suspending filament in midair is very delicate. It's possible depending on the situation, but if you go over long distances, it'll start to droop and delaminate. So you can have the slicing software put in supports, and the software has gotten so much better that it can recognize where it needs supports and automatically put them in for you. As I said, there's so much adjustability to it. You do multiple parts. You can fill your bed with the same part. You can even nowadays you can even actually add embossments, text, stuff like that. These little battery holders I downloaded from Thingiverse. I added a little HCRA text on the back of it just using the slicing software instead of having to go into CAD and design it into the CAD file. So that saved me a ton of time. And what's great about the slicing software, it has preloaded configurations for exact printing, especially if you buy a Prusa or a Bamboo Labs. They have software that's dedicated to your printer. So that can help you out. It takes a lot of the guesswork out. It takes a lot of the tuning out as well. Some software have preloaded materials for the filament you're using, for the quality you want. They fine tune it. The community has fine tuned it. So as I said, it's gotten a lot better over the years. The popular software packages for slicing for taking your 3D model and creating the G code is, HCRA, it's still a popular one. Slick 3R, or the slicer, some people call it, that's free as well. Depending on the printer you buy, some of them have proprietary software like Bamboo. I have a Bamboo Labs A1, that was my recent printer, and it has its own software. I was a little concerned at first, because I'm not a big fan of proprietary software with 3D printing, but it has been proven to be good, and worst cases is I could still generate G code using a different piece of software. The reason why I'm sticking with the proprietary software Bamboo is because it supports features that the printer has that other slicing software can't do it. So the software was designed around the printer. What's cool about the software was also give you an estimate for filament usages and costs. So when you generate the G code, it will tell you exactly how much filament it will use to create this part. And from there, you can calculate exactly how much it costs. For example, this one uses 100 grams of PETG carbon fiber. And so a 1 kilogram spool cost me $30. So I figured out with the energy, power, and filament, you're looking at 40, 50 cents a part. So the prices aren't bad. So the typical process, you think of a problem or a thing you can want to make that can be solved with 3D printing. Did someone else think about it? Search the repositories. Someone most likely thought of it. Hopefully they thought of exactly what you wanted. If not, you can design it using CAD software. It does take time. You can generate or download the STL file within the CAD software, import it into your slicing software. You choose your settings, profiles based on the model or the material. And then this slicing software creates the G code that it will either send it to your printer or put it on a little card or a CF card, a SD card, and you can put it into your printer. It will also, then after that, you set up your printer, you power it on, you tell it what you want to print. You might have to do some, depending on the printer you buy, you might have to do some pre-steps like leveling the bed, testing swapping filaments, doing extrusion tests. That all depends on the printer you buy. And of course, the printer operation itself, and then afterwards, it's the finishing. Some of these you see up here came right off the printer. I didn't bother doing anything to them like these covers for the IC 705. These I did a little post-processing. I took a sand, I'd steal my wife's nail files and use them to rough around the edges. So she got mad of me stealing her nail files, so she bought me a box full of them. And that's something I love. And then with 3D printing, things go wrong. I'm not gonna sugarcoat it. Things can go wrong. So what happens when things, what a lot of people will do is will print. You'll see this a lot if you get into 3D printing. It's called benchy. Right, Jurgen? And where Jurgen has this benchy. Benchies are used, it's basically used as a standard. And it tests your printer's capabilities. So you can tell by printing a benchy what's going right and what's going wrong with your printer. For example, there's text on the bottom of the boat. So if the text isn't coming out clear, that means something's wrong with your first layer or the second layer. There's text on the backs. So if you see a lot of echoing, like a lot of waviness around the text, that means your printer might be not on a nice tabletop or not on a firm surface, so the printer might be moving around. A lot of people will buy, I buy patio blocks, and I put my printers on patio blocks to help absorb some of that echoing. It also will tell you about bridging. This is done out of PETG, so it bridges over the cabin of the boat, so it shows you how well bridging is. It'll show you how well the texturing. So these little benches, you can come up here later and look at them. It'll tell you exactly how well or how bad your 3D printer is. Jurgen brought in a nice little test fixtures. We call these print towers. And the one that Jurgen brought in here will calibrate. Well, it has the G code. Will tell it to change temperature of the nozzle, and it'll print a little tower for each temperature change. And you can dial in your filament, your settings that way as well. And this one looks like it tests how well it does with bridging, how well it does with text. And it looks like it does how concentric. There's a little needle in here that if the needle is perfectly pointy, then you'll know it's within calibration. There's also other things you can use. There's tons of little blocks. A lot of people print these little XYZ blocks that will help you out. So if you ever run into a problem, there's a huge community out there for 3D printing. You can go to the community, and usually the first thing they're going to ask you is, "Did you print a Benchy?" You can send a picture of your Benchy, and then they'll tell you what's wrong with your printer just based on the pictures alone. So that's pretty cool. As I said, there's a ton of communities out there. They're out there to help. You just got to find the right one. So the causes of most issues, because you are going to run into issues. I wish you wouldn't, but you will. A lot of it has to do with bed leveling. These 3D printers love to have a level bed. If there's any waviness or it's askew the bed, or someone pulled up on it, or it crashed into it, happens. The print won't come out right because it's basically like building a house. If you have a bad foundation, everything else after it is not going to be that good. So that's usually the biggest cause of issues. The cool part is if newer printers out today have sort of solved most of the bed leveling issues. Back in the day, you had to adjust these little screws and slide index cards underneath the hot end, and you had to do it in multiple spots around the bed. Now there's software. For example, this was 2015. There is a proximity sensor here. They call it a Pinda Pro, but it's just basically a proximity sensor that goes around and measures the distance of each of 9 spots on that. Nowadays, the nozzle itself is a proximity sensor, and it will touch the bed, move along, and now you can do mesh beds, and it's insane at what you can do now. So bed leveling, if you buy a cheaper printer, yes, it's a big concern. Bed adhesion, your first layer, as I said, is your foundation. Some filaments, some beds don't like to stick to each other. So a lot of people, back in my day, 10 years or 15 years ago, we used a lot of painter's tape. We would put painter's tape upside down, and we use a lot of these glue sticks. My kids don't like me because I steal all their glue sticks, but it's still an issue, especially if the more and more you use your 3D printer, and if you especially using the same bed. Oils from your fingers, oils from the air, they get stuck on it gets attached to and sometimes the filament doesn't stick. So proper maintenance, which I'll go over in a bit, will help. The speed, it's possible to go too fast. It's also possible to go too slow. That all depends on the filament, the ambient temperature. There's all these little factors at play. Cooling, especially if you're trying to do bridging, using the filament, like basically printing over a gap, that will need to be cooled down as it's printing. So with this particular printer, you'll see a little squirrel fan right here, and that will force air down around the nozzle to cool the filament as it's printing. So hopefully it stays where it printed. But sometimes it doesn't cool it fast enough and the filament starts to droop. So that causes an issue. With the PETG, as I mentioned earlier, it gets gooey. So some printers, as it's printing, it's oozing out while it's in between layers or in between jumping to another feature. Sometimes will goo out and you'll get like a little blister, and then you would have to adjust what's called a retraction setting, which will suck the filament back in, but you don't want to. So that's where all the little fine tuning comes to play. And as I said multiple times, that technology has been improving a lot to where it's not as bad as it used to be. Temperature or extrusion, and of course your environment. If you have your printer in like a basement, it's very humid out, or very humid in your basement, it can really affect your print. So those are the things to consider when things go wrong. Maintenance is key with anything. Maintenance of your car, maintenance of your house. 3D printers need maintenance as well. If you're buying a 3D printer, I always suggest to people to buy some extra parts. Those include the nozzles and an extra build plate, at least those 2 things. Because you will clog a nozzle, you will ruin a bed. And the beds are not infinite, you will wear through them. There's belt tensioning. You know, if you bought an older printer or a very, very cheap printer, you might have to be constantly adjusting the level. Sometimes the extruder gear, what happens is when the filament comes into the extruder, there's these two little gears that pinch the material and force it down through the nozzle. Sometimes those get clogged up with little bits of plastic, or they wear away if they're plastic. A lot of the good printers will have metal wheels, extruder gears, so there's a lot of little things that can go wrong with that. As I said, this isn't for everybody, but it's great. Yes.
How hot is the extruder?
The extruder can get up to 600 degrees Fahrenheit. The bed will get about 250 degrees Fahrenheit. So it can get up there, and then also the extruder can wear depending on the material used. PLA, PETG is fine, but things like carbon fiber or wood, it puts little particles in there that will sand and grind away the nozzle diameter to make it bigger or smaller. Make it bigger, and it can cause issues. So some people suggest getting hardened nozzles, which will help with that, or just have multiple nozzles on hand. So if you're in the market for one, what do you want to look for? Well, of course, safety. I explained a lot of that earlier. A lot of the safety, I would say wouldn't be a key focus. I started this presentation actually 10 years ago, and I just been slowly updating it. I would definitely Google the printer you're thinking about buying, and I would add the word trouble, issues, just to see what the common issues are with those printers, especially if, they're not like the A-net A8 is known for catching on fire. You probably want to avoid a brand new A-net A8, but they don't really make them brand new anymore. Considering the bed size and build area, it depends on what you want to do. Some people are fine with a little tiny bed, but most beds are about the 10 by 10 inch area for FDM printing. But if you need something bigger, there are bigger beds out there. It will be more expensive, but there are out there. You might want to consider whether or not the printer is open source or not. The Prusa's are very open source. Creality Enders are basically open source. The printer I bought, the Bamboo A1, is not open source, but I knew that buying it to me is a purchase well worth it. What type of extrusion system you might want to consider? Like the ones you see here on this Prusa is called a direct drive, where the extruder servo and the extruder itself is mounted to the rail, to the x-axis. Some printers will have a servo sitting up on top, which is called a Bowden. There are some pros and cons about using Bowden versus direct. For example, if you use a Bowden, it puts less stress on the X carriage. With this one, I have an aftermarket extruder on it, and this adds quite a bit of weight. So some people want the servo and hardware up here and just feed the filament directly into the hot end, and it's a lot less weight, a lot less stress on it. But the downside is it creates more clogging issues, especially if you're using flexible filaments like TPU. It will bind in that PTFE tubing you'll see here sticking out. This PTF tubing would go all the way up to the extruder, and it would clog, bind up in there, and you get blisters in your print and stuff like that, bad quality edges. So there's pros and cons about it. Another thing to look for is multiple nozzles or extruders. Or nowadays you'll see like with the Bamboo Labs, they have what's called the AMS, where you can load up 4 spools of different filament, and it will feed it into one nozzle. And they call it the AMS, and it has 4 different motors that can feed different filaments at different times in there. So you can use a water dissolving filament for your supports, and it would switch back and forth layer by layer. But the downside of using multiple filaments is it creates a lot of trash. They call them boogers, snots. I should have brought some with me. And in some projects, if you're using 4 colors, it creates a lot of mess because it has to extrude in between color changes to clear out what's in the PTFE tubing. So that's also another thing you need to consider if you want to get into something with multiple colors. Then you have computer controlled versus computer independent. Most of the 3D printers now, they can print by themselves. You can load external media like an SD card, or you can run it over your network. But there's some people that want it completely independent. There are some printers like the Bamboo P1, I think requires a network connection. And then of course the features versus price. There are a lot of upgrades you can do, especially with the lower end printers. A lot of people will buy a lower end printer and turn it into a higher end printer by printing a lot of the items. So some people use it as a learning exercise to get them on their way. Even with professional, more expensive printers, you can still print little things to make it easier for you. It all depends on yourself. That allows you to buy a cheap printer in some cases and test the waters. Some of the upgrades include going from 12 volts to 24 volts. That Prusa right there is a 12-volt system. A lot of the older printers were using 8-bit boards, so you can swap them to 32-bit boards. You can swap hot ends. I did that on that Prusa. It had an E3, they call it a V3. I went with a Chimera because I wanted to print TPU. You can replace the bed with glass or spring steel. There's all sorts of things you can do. It all depends on the printer you buy as well.
Yeah,
Yes.
for a novice like me, is there any, magazines, hobbyist magazines that talk about this stuff?
I have personally not looked into magazines, but there are a ton of websites out there, tons and tons of websites. And it's mostly at those repositories where they're all talking about 3D printing. Printables.com is a big repository, a big forum for talking about 3D printing, especially if you own a Prusa. If you have an issue with your Prusa, they have a good community. A lot of the printers are making their own communities based around their printer that you can go and say, hey, I have an A1 or I have a MK4 and it's doing this, and they'll generally tell you to check X, Y, Z or something like that. So as for magazines, I can't tell you, I'm sorry.
Okay.
Cool thing about 3D printing that a lot of people are into, I should get into it because I'm not really organized, it's called Gridfinity. And I made a slide for this because a lot of hands are into Gridfinity. It's basically a 3D printed shop tool storage system. So if you're a neat freak and you want your tool drawers to have every socket in its place, and you want to open a drawer and say, hey, that's my 10 millimeters missing, because it will go missing. You can at least see it if you use Gridfinity. So what it does is it prints these little 42 by 42 square grids. You put it on the bottom of the toolbox or in a drawer, and then you can print items that snap into those, and they have different items. And the cool part is it's open source. There are thousands and thousands of people designing things that snap into these Gridfinity, and you're seeing a lot of ham radio uses, resistor holders, helping hands, if you have a lot of like little electronic components, you can make little drawers. Sky's the limit when it comes to organizing with 3D printing. It's also a perfect way to keep your printer busy. A lot of people will buy a printer, print a couple projects, and it just sits there doing nothing, which is a typical case. But if you get into the Gridfinity stuff, you can always have your printer doing something. So if you don't have a concern about your power bill, definitely consider the Gridfinity. So these are my current recommendations. Based on I've polled many people in the amateur radio community. There's chat rooms I hang out in all day that we all talk about 3D printing a lot, and I developed a list of 3D printers that if you were to get into 3D printing and you don't have a 3D printer, these are the ones I would recommend. I start off with the Cobra 2 Neo. I personally never used one, but from what I've read, they're very good, but they have manual bed leveling. I'm not sure about who here had a Cobra 2?
I have the Cobra 2 Pro.
Does the
and it's
Pro
auto leveling?
auto leveling?
Out of the box, I didn't have any problem.
So I think the Neo had manual leveling, but I picked that one because it was the cheapest entry level decent printer that you can get. There's a lot more upfront work with it, but can't complain. So you had the Cobra 2 Pro. Do you remember how much you paid for it?
$199.
So for $50 more, yeah, you can. That's probably why I wrote $199. But it's always on sale. They're always on sale for some reason. The next one I would suggest that a lot of people use is the Creality Ender 3, and there's different variants of the Ender 3. I would personally suggest to spend the extra money and get the KE version. It has a better access. It has a better cooling features, all metal hot ends, It has a PEI bed, so it makes it a little more flexible, a little easier. So I would suggest the KE version, but if you're very tight on money, the SE version is just as good. The Bamboo A1 Mini, Bamboo Labs has been taking over 3D printing by storm because their printers are cheap and they're really good. As a matter of fact, they're so good they got sued. So there's a lot of people thinking that they're gonna go away. They're being sued by a major 3D printing manufacturer called Stratus, because they stole an idea that they print little towers as they do multiple color changes. So they're being sued, but they're great printers. I have the Bamboo A1. I paid $339 for that. For me, money well spent. I had it going within 15 minutes, and I barely had any issues with it. I'm not saying that you'll have the same experience. I hope you do. But I don't think you can go wrong with the Bamboo stuff. The Elegoo Neptune 4, I heard great things about that. I personally never used one. I've used the Ender 3. Another one that I came across that was pretty cool was the QIDI Tech Q1 Pro. A lot of people just call it the Q1 Pro. It's a little more expensive, but it's fully enclosed. And it's a heated chamber. So if you're trying to put this in a basement that's not really temperature controlled or in a garage, and you wanted to keep it away from you, you don't want to be smelling anything, that would be a good printer because it keeps the area, the printing area within a temperature control and humidity control, which is beneficial to making a really good print. Another one I would suggest is the Prusa MK4, which is the much newer variant of that one. Anything Bamboo and Prusa is decent. Also consider the cost for consumable items such as nozzles, hot ends, build plates, and stuff like that. Consider those costs because some people, will have cheap printers, but the nozzles will be like $60, where I can get a more expensive printer but get nozzles for $10.
So we bought the Bamboo PS1.
Yep.
And it's printed over 500 parts already, and that thing's just, it's working right now. It's printing. It's crazy.
Yeah, I got my printer going right now. I was gonna see if I can connect to it.
And it takes, it was no time to set up, and it's so easy to change out spools and everything else. It's super simple.
The A1, the knob, like with the Prusas, if you had to change the knob, you have to let it cool down, unscrew it, unscrew it back in, reach out. With the Bamboos, you just
bam, a
little clip, pull it out, pull a new one in, and you're back in business within minutes. So as I said, you get different prices. You got $149 versus $800. They both print stuff. So what makes it the difference? It's the features and the software and the support behind those prices that make it different. So you can get by making 3D prints with a Cobra 2 Neo or the Cobra 2 Pro, no problem. The more expensive printers start offering more features. Like I don't think I'll ever go away from Bamboo unless something else really comes out better. Jurgen.
Jeff, I don't know whether all of those have automatic leveling, but I would not recommend any printer that has not automatic leveling.
I would agree with that.
Yes.
But that all depends on your wallet. But that's where most of the that's what happens is a lot of people buy a 3D printer. They'll try printing something and no, nope, not for me. And I can understand why, because I've been frustrated myself to the point where I just left it on my shelf for a year or two because I just didn't want to deal with it. Like that printer is a prime example. Even though that it has auto bed leveling, it's not as good as what you have today. That usually proximity sensor and it's not really finely tuned. So I would totally agree with you, Jurgen. Spend the extra money, it saves less aggravation. I know there are a lot of penny pitching hands. I'm one myself. And my wallet hurt a little bit when I spent $339 on a printer, but compared to that and compared to especially the ANET A and the mono price ones I had back 15 years ago, it's a world of difference. It's great for the home user. Instead of turning in, a lot of people now use them as tools for other hobbies instead of making a hobby out of it itself.
Commercial printing with it.
Some things I wish I knew prior to 3D getting into 3D, prior to diving into it. Patience. You'll need a lot of it. Even if you buy one of these nice printers that does everything for you, you still need a lot of patience. Some prints take a long time to print. For example, this little Wolverine on the resin printer took almost 9 hours to print. This IC 705 cover took about 2 hours of print, 3 hours of print with the bamboo. This took 6 hours of print. So you need patience, and you also need patience if things go wrong, and things will go wrong. There's not, another thing I didn't really touch on is like filament storage. A lot of people will buy spools of filament and leave them out in the open. I'm one of those people. And what happens is, depending on the type of material plastic, it will absorb water. And what happens is it will get in an extruder, heat up, and that moisture will turn into steam and it will cause pops, blisters. It can also, with PLA, especially with PLA, if you leave it out, if anyone had left a spool of PLA out and they go to put in their printer, the edge will start snapping. I see, I just snapped it right here, because it just got, and you don't want that, because what happens if it snaps, and it goes into the extruder, now there's a gap, and sometimes the wheel will not push that down, and then you start getting a clogging situation. So some people really go down the rabbit hole with their filaments, and they'll put them in humidified, humidity controlled boxes, and they'll have little meters on each box, and yeah. I'm starting to find, I started to find that out, with these things. So I bought a roll of filament just to print these things for the club. And I left it out for 3 days, and I'm already getting blistering with this stuff. And I should have immediately unwound the spool and put it in what a lot of people do is they'll buy large Ziploc bags and get those desiccant gel packs, and they'll fill them with that, or some will go all out vacuum seal and put them in. They have special sealed Tupperware containers that have, humidity sensors built in, and some people will buy food dehydrators and put the spools in food dehydrators, and they'll put them in, if you have electronic ovens that can, I would never put a spool of filament in my house oven, but people do it. And what's that?
Where's a cigar case?
Well, that's the thing, you gotta control the humidity you don't want it to be humid.
You want like
humid-
10%.
You don't want a humidor, you want it, what is it, 10%?
It's about 10-15% is what we run ours at, on that
Yeah,
PS1.
there are people, I have a table full of, but you know what? With my bamboo, I loaded up an old spool, thinking it would be just fine. Nope. Getting clogs, breaks, it was more frustrating. I just ended up buying a new spool, and it helped out. Spools of filament, usually come in 1 kilogram rolls. They go for about $20 on average. Some are more expensive, some are cheaper. I will say though, don't go with the cheapest one, because they're wound horribly. They'll start getting knots, or cross over each other, or it's just crap material, and it just causes more problems than ever. So, dry filament, happy filament. Bed limit sensors, I said most newer printers are already taking care of that. I keep a log whenever I print something. If I buy a brand new roll of filament, I will print a benchy or something real quick just to see how well it will react. And I will make a label, and I'll stick it on the side with what good temperatures it can print at. With the bamboo, I had to really make many changes, but because it can handle a wide variation. But some filaments are very picky, some printers are very picky, and it's best to keep notes. I write them on the spools themselves. During troubleshooting, this is one of my big issues, is something went wrong, I start changing all these things. Going through changes, and sometimes it works, and well, geez, what did I do? I don't know what was the change. So do one change at a time. Yeah, it takes a lot longer, but you'll be able to dial it down. And after time goes on, you'll start seeing an issue and be, oh, I know what to do. Da 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 da. So that's where it can turn into a hobby of its own. But if you start designing your own parts, factor in tolerancing. A lot of people will design their parts line on line. Printers have about a 20 thousandths tolerance. For some people, that might be perfectly fine. My industry, I would have gotten in trouble over 20 thousandths. But with some good, with good tuning and with the newer printers, you can get down to 5 thousandths, which is a good standard in this hobby. With the resin stuff, you can get down to the thou, so 0.001. So, but if you're designing something, especially if they're fitting within each other, try to create some wiggle room. So if you're trying to put like a 1 inch peg through you don't want to put a 1 inch hole, you want the hole to be a little bigger, you want the peg to be a little smaller. So factor that in when you're doing CAD design. I designed a lot of stuff online and ended up regretting it, doing a lot of sanding. So, any questions? Larry?
Yeah, you said the nozzles clog up. What are they made of?
The nozzles are usually made out of brass. They could be made of aluminum, or they could be made out of hardened steel or some combination, depending on the make and model of the printer.
Don't they have any coating they can put on the inside of them that?
So some nozzles have a PTFE coating inside the nozzle
Yeah.
that allows it to guide it right to the tip of the extruder. Some don't. It depends on the manufacturer, the type of nozzle. Like with the bamboo, their nozzles are proprietary, whereas the Prusas, the Enders, they have changeable tips that are standard. So so you can buy hardened nozzles, especially if you're printing with things that are abrasive like carbon fiber, wood. You definitely would want to get a hardened nozzle for that. Steve?
When I was in the wire and cable industry, we used nitrided dyes. And I suspect that nitrided dyes may be available for these things.
I have not looked into that.
All right?
I will.
Really, really hard and they don't clog.
I'm sure it would be being used by now because as I said, there's a lot of open sources to it, there's a big community. I'm sure it's been tested, might be out there. I haven't looked into it personally.
Okay.
Any other questions? Alan?
There are desktop CNC machines that are in the same kind of price class, hobbyist type approachable thing. That could potentially make some similar things. Obviously, it's a different process. It's subtractive rather than additive. Are the hobbyist grade CNCs just not worth bothering with, or is it just that more people are doing 3D printing?
It's application specific. For example, a lot of people buy CNC routers.
Right.
So if you're doing a lot of wood projects, CNC router might be good. I want to use a 3D printer to do wood projects. So then you got the desktop lasers, the CO2 20 watts. Now they're coming out with 60 wires for desktop. And that's great if you're trying to engrave stuff or cut balsa wood or certain thicknesses of metal. Yeah, that's perfect for that. I guess it all depends on your application and your wallet. Because 4K know those bills. Why don't you can buy both? Paul.
I'm assuming from what you said that the answer to this question is no, but I'm assuming that
No.
once you start a project, you're committed to it to the end. You can't like stop at 4 o'clock and decide I'm gonna pick it up on Saturday morning.
Actually, you can do that.
Oh, really?
Yes, especially with the newer printers.
I thought because the heat is involved, we might not be able to do
That can factor into it.
Yeah.
But what I normally suggest to people is you don't want to cut, so you can pause a print mid-print. Actually, with some printers, if like for example, the Prusa right here, the bamboo A1 I don't have the multicolor. So if I want to switch colors, I can actually stop the printer, change the filament so I can change color, and then resume. So what a lot of people do is they'll make like a hammer, the True SDX, for example. They have embossed text sticking outside the case.
Right.
So what a lot of people do is they'll print the flat part of the case, and then once it starts doing the text, they'll insert a stop into the code. It'll tuck the head, move it away, it'll pop out the filament, it'll allow you to load in new filament, hit a button, and it would resume. You could do that in the slicing software, put a stop point in it. And you can change colors. And yes, like let's say, I'm not too comfortable having my printer running by itself. I'm getting more comfortable, but if I'm doing a 24 or 48 hour print, which there are prints like that out there. Yes, I would suggest not stopping it after the first layer because the first few layers is key, especially if you're having your printer out in the open. Because what happens is if you have your printer out in the open, the edges can curl up, especially if you're in a basement, garage where it's cold, and the heated bed. It will curl the edges of the material and it makes a big difference. So you might want to consider enclosing your printer, but that's why I suggest to stop like maybe 20 or 30 layers up once it's been established. Then you can pause it and return to it, and you won't have much of an issue. Nothing you can certainly Worst cases, you might have to put a little spot, filler, like, Bondo type stuff in, but very rarely does that happen. Any other questions? All right, wow, 9 o'clock, well, I thank you guys, if you want, you can come up, if you have a Baofeng UV5R, I'm sure most of you do. You're more than welcome to, grab one of these, first come, first serve. You can't take the 705s, I might take one, but, they're not mine. Jim and Frandy brought their 705s because I made covers for them, and, I did ask them to bring them in, and so you can see how well it fits, and I didn't design this, I actually downloaded up Thingiverse, and who here has a 705? Oh my gosh, I wish I knew that, like, well, you guys could fight over this one. If you want to cover, if someone has a shallow 705 and don't want a full cover, just cover the VFO knobs or whatever, you can have this one as well. So anything on this corner of the table, you can have, if you have a UVK5, the newer Baofengs, I have a couple little desktop things for that. So with that, I appreciate you guys. My call sign's NT1K. My email address is nt1k@nt1k.com. Very hard. So if you do have questions about 3D printing, you can certainly reach out to me. I may not get back to you as fast as you might want me to, but I will get back to you and I will help you out as much as possible. That's what I enjoy about this club. And if it seems like there's a lot of people, who here has 3D printers? Jeez. Wow. So maybe it's worth doing a shared knowledge, especially, what would be your weaknesses in 3D printing if you had any? Would it be design or would it
Design.
be 3D printer operation?
Just designs.
All right, so maybe we should do a shared knowledge down the road on CAD CAM or computer aided drafting and how it applies to 3D printing. So we definitely can do more with this. I didn't really that many. I mean, I had people come up here bringing their 3D printers, like look what I made and stuff like that. Charlie, Jurgen, Bob, YO, I think had something. So there's a lot of cool things you can do with it, and that's why I wanted to share it. Because there is applications for amateur radio with it.
Quick question. So when you download from Thingiverse or Yagi, printables, whatever, and you get that SVL file, on my Bamboo, I can take that same file, I can just drag and drop right into the Bamboo and it will automatically load it. Does the other like Prusa and Neptune and all,
Also depends on what slicing software you use.
okay,
too.
gotcha.
For example, like the Ender, you might use Cura, there's Slick3R.
Okay.
The Prusa slicer, which is a ripoff of Slick3R, a forked version of it. A lot of people, even though it's not a Prusa, will use the Prusa slicing software on their printer. And as I said, it's a lot of open sources to it. So a lot of people will create drivers and profiles for those printers that you can load into the slicing software.
Like let's just drag and drop that file in there. It's so easy to go print something.
Yeah, but with the Bamboo Labs, they have proprietary software, and that's because there's features on those Bamboo printers that you don't have in slicing software. Like, for example, the A1 I have has a camera lighting system that I can turn on remotely. As a matter of fact, I have an app they call Bamboo Handy or something like that. And I can actually monitor my prints over my phone.
It's
like control the printer over the phone. So another thing I would also add that I didn't add into a slide is called Octoprint. If you have a Raspberry Pi sitting around doing nothing, there's a cool thing called Octo Everywhere. And basically you take a Raspberry Pi, you can hook a web camera up to it. And the Raspberry Pi acts as like a little web server, so you can remote in from anywhere in the world and control your printer. So if your printer doesn't have those features, you can add it with Octo Everywhere. And what's really cool about Octo Everywhere is it's starting to using the AI stuff, so it can detect if your print fails midway print. Like if you're away from your printer, like you go to work, you leave your printer running and it starts turning into spaghetti, it will recognize that it's failing and it will stop the printer for you. Some of the newer printers, especially the MK4 Prusa, has that built in. But with Octo Everywhere or Octoprint, you can definitely upgrade your printer to basically be like a Flex. You can use it remotely. Problem is you have to go home and clear the bed. But there's printers now that will wipe the bed for you too, depending on what you print, and start new. So the sky's the limit when it comes to 3D printing. Is there any more questions before I turn it back to Alan? All right, thank you guys for listening to me. All
All right, thank you, Jeff. Awesome. Yeah, now I've got to get one of these.
Yeah.
Especially since I see everybody else has them.
No, you just come use ours.
Yeah.
It's like a boat.
Exactly.
You have a friend with a boat.
Yeah.
Use theirs.
You got it. Right.
Exactly.
Right, a couple other announcements, before we all check out the toys up here. October 12th, next Saturday, we are having a cookout, picnic in School Street Park, same place we had our field day. We have the park reserved, we have the pavilion in the park reserved from 9 to 5, we've got it for the whole day. Show up around 10 would be fine, we're gonna make it a lunchtime kind of event. We're all set with a lot of the background stuff, but we would like people to bring potluck side dishes. Okay, so we will be providing meats and buns and grillable stuff and condiments and cups and sodas. If you can bring some salads, some desserts, that kind of thing, I will post on the email list about this, and people can chime in with what they're bringing, so we don't get 12 desserts and no salads or vice versa.
12 baked beans.
And we're gonna, just, it's a casual event. We'll go to the park, we'll have some food, we'll hang out, and bring radios.
Yep.
Bring your portable radio setups. There aren't really good antenna trees anywhere near the pavilion. So if you have antennas, they should probably be self-supporting in some way. But bring your setups. If you don't have anything in particular, just show up and check out what other people have. It'll be a good time next Saturday. Next meeting is November 1st. It will be our auction, which is always one of our most popular events. Ham radio gear, no computers or computer parts, but all kinds of radio gear is fair game. Bring it in, we'll auction it. Club gets 10%, you keep the rest. Pretty good deal, and there's always a good assortment of stuff there. And let's see, other general announcements. If you manage to get some coffee and donuts, thanks, Smitty. Thank you, Smitty. Paul, outgoing QSL cards.
Last pass went out, this past week, so the next round will be target mid-January.
Okay. We have a new treasurer, Michael, KB1WAM. If you are buying something on behalf of the club, he will handle reimbursements. He'll do all the treasurer stuff. Thank you very much for that.
Thank you.
Thank you, George.
Yes. We're staying on longer too.
Yes. Staying on long enough, Michael. Speaking of money, dues are due, so we can do all the things that we do. I mentioned we're gonna have meats and buns and sodas and everything. That's all coming from the club funds, which come from people paying their dues. They expire at the end of August. There is a list on the back table. If you're highlighted, it's because your dues expired, and as of this morning, I didn't have any record that you paid. Maybe you ought to do that. There's a stack of membership forms there as well. You can also go on HCRA.org and do it through PayPal, which is probably more convenient. All right. Also on the back table, there's some stuff, some t-shirts and some other things with a sign on them that say free. It's because they're free. Please take them. There was also a casserole and a serving plate and a serving spoon. If you are the owner of those, please take them. If you see them still there, please take them. I do not want to take them home. They are free game for anybody here. They're just going to Goodwill if I have to take them home. All right. Other stuff, the weekly 10-meter net, Monday nights, 28,375 megahertz. Join us. It's been a good time. Listen for Gary, W1JZR. He signs as W1NY, the club call sign. And latest issue of Zero Beat Club newsletter is on HCRA.org. I am doing a half-assed job of editing it because Ken is still not quite neck deep anymore in housework, maybe like chest deep.
Starting to get a little better.
Starting to emerge. If you're not on our email reflector, sign up, please. It's hcra.groups.io. That's how we keep in touch and organize stuff in between meetings, like post about the picnic. You might want to keep track of that. Final two items. You can turn your phone ringers back on, and I see I have texts from my wife already. Yeah, re-enable those so you get your texts and drive safely on the way home. Thank you very much, everybody.